Okay, hi everyone. We're just going to start now, so not going to be waiting for any more people to join. Let me share my screen. Okay, so this week we're going to be talking about second generation blockchains. So in the first three meetings, we talked about first generation blockchains. So for example, Bitcoin, Litecoin, just blockchains that require proof of work or crypto mining. And that's been our main focus for the last three meetings. And in our last meeting today, I think that it would be good if we talk about second generation blockchains. So as a bit of context, second generation blockchains were created later with a different system of validation called proof of stake. And it aims to address the environmental issues of proof of work. So, you know how proof of work requires massive amounts of computation. Well, proof of stake aims to address that by introducing a different type of validation protocol. So the agenda for today is first, we're going to talk about, no, well, first is going to be any questions. And then second is a quick recap of what we talked about last week. And then we're going to talk about smart contracts. Then we're going to talk about the Ethereum virtual machine or the EVM. Then we're going to talk about Ethereum structure and proof of stake. So I chose Ethereum as an example to talk about second generation blockchains because it was quite revolutionary, and I think it's a good example of how second generation blockchains operate. First of all, is questions. So any questions that anybody has, just feel free to ask. Just unmute your mic and ask, or you can also send them in chat. So let's go over a quick recap of what we learned last week. So we talked about, I have two things on here, but we've talked about four main things. So first is encryption. So encryption comes in two different main types: symmetric key encryption and asymmetric key encryption. Symmetric key encryption is where everything is encrypted the same way and therefore also decrypted the same way. And that doesn't work. So that's why blockchains actually use asymmetric key encryption, where everything has a different method of being encrypted. So for example, all the wallet addresses are encrypted in a different way, so that in order to decrypt them, all like decrypting everything, anything will have a different method. So the specific implementation of this in blockchains is elliptic curve cryptography, and yeah, so that's encryption. Next, we talked about the criteria for encryption. So everything has to, all the private keys has to be different, and everything needs to be encrypted differently so that they can't all be decrypted using the same strategy or pattern. And then we talked about hashing. So hashing is simply a function or a method of providing power for encryption functions. So for example, elliptic curve cryptography obviously needs computing power in order to encrypt everything, and that's what hashing does. And we talked about two types of hashing: a tree structured hash and a simple hash. And a simple hash is where you line everything in linear order and then you hash each of them one by one. And then a tree structured hash is where you put everything on these nodes called leaves, and then you hash them by going down the tree. They both end with the same result, but they're used in different cases. Third is transaction integrity. So we talked about how everything needs to have a unique address. There also needs to be identification of the participants. Not identification in terms of saying what's your name, age, where you live, etc. Identification as what's your private key, what's your public key, and what money are you sending. And the third criteria is verification of the contents of the transaction. So am I really receiving what you're sending, or are you really receiving what I'm sending? And how they verify this is cross-checking with the public key of the receiver and the private key of the sender. Did the data from the private key of the sender actually go to the public key of the receiver? And lastly, we talked about crypto mining. And essentially, crypto mining is just the word to describe the function that gives power to hashing and encryption functions. so for example, the process of crypto mining is miners use mining software to use to that leverages the power of their computer to then to then complete these hashing functions, and they also and for a reward for taking on the extra responsibility, they compete for broadcasting new blocks. They compete for that, and then there's the new coins minted each block that's given to the miners who actually validate that block. So that's the incentive or the reward for mining. The third thing we're going to talk about today, so after the review, is smart contracts. So now we're going to start moving into second generation blockchains and seeing how they work. So recall with Bitcoin or any first generation blockchain, in any block, there's only and any transaction, there's only transactions and UTXOs. So in blocks there are transactions, and in transactions there's only UTXOs. And so it makes transactions on first generation blockchains really, really simple. So your wallet address, how much you sent, the other person's wallet address, how much would they receive? And that's essentially it. However, things are a little bit more complicated when it comes to Ethereum or second generation blockchains, such as Ethereum. And for a little bit of context, second generation blockchains were developed in around 2015, and so they've been around for quite a while. But the most notable example is Ethereum, which was a proof of work blockchain, but then transitioned to proof of stake in I believe 2019. And yes, the main difference between Ethereum and other second generation blockchains and first generation blockchains is a smart contract. And before I mentioned that second generation blockchains were created in order to solve environmental problems, smart contracts provides a method to do this. So essentially, when in a transaction on Bitcoin or the Bitcoin blockchain, the Bitcoin blockchain only supports a transfer of value. So as I mentioned before, it only really supports adding some specific number to your wallet, crypto wallet, and subtracting some amount from another person's crypto wallet, which is them sending some money to you, right? So it only really supports these really, really simple transactions of data. However, smart contracts are a little bit more complex. So smart contracts, I guess, let me talk a little bit about the history again. So smart contracts were developed by Nick Szabo, so the same guy that failed to create the first blockchain. So if we can remember, Nick Szabo tried to create something called BitGold, and it didn't work because of the double spending problem. So he kept working on cryptocurrencies or blockchains, and he eventually conceptualized the smart contract as, quote, computerized transaction protocols that execute the terms of a contract. So as you know, contracts are a little bit more complicated than just, a transfer of value. They might include terms on which they can be spent. They can include a bunch of other information that are more complex than just adding some number to your account or adding some number to some other person's account. And smart contracts were made to work specifically with the Ethereum blockchain. And so what are they actually then? So smart contracts are essentially more complex versions of transactions that have the same core concepts and characteristics, like being irreversible and transparent, as well as, obviously, exchange of value between people's crypto wallets, right? But one thing they do is that they're able to specify more than just the transfer of data. So, for example, they can specify the date of transfer, the requirements for transfer, conditions under which the money can be claimed, etc. So you can think about it as how, for example, in an auction, there might be specific requirements for you to be able to bid. So you might have to be over 18 or you might have to bid a specific minimum amount of money. And that's what smart contracts are able to do. They're essentially a contract that can specify more complex things than just a transfer of data. So another example is sort of like coding. Bitcoin transfers are like functions or methods, so you can only really call them in one way. But smart contracts are, for example, with are classes where you're able to define more variables and have multiple methods and functions in them. So they're just more complicated overall. And similarly to, of course, Bitcoin, which needs power to, process its transactions, smart contracts also need the power to process and run. And that's where the Ethereum virtual machine comes in. And what's actually really special about the Ethereum virtual machine is that, for example, when you look at Bitcoin, when they need to validate transactions, it's really like power intensive, bad for the environment, etc. But the Ethereum virtual machine and proof of stake actually takes care of that. So let's first talk about the Ethereum virtual machine. Again, we're trying to build from the ground up. So talking about smart contracts, which is a basic building block of the Ethereum blockchain. And then we're going to talk about Ethereum virtual machine, which is responsible for actually running the Ethereum blockchain. And we're going to talk about Ethereum blockchain, and then in general, proof of stake and all other blockchains that also use proof of stake. So what is the Ethereum virtual machine? Well, the Ethereum virtual machine is responsible for executing smart contracts. So just like the Bitcoin blockchain uses hashing functions and elliptic curve cryptography to process its transactions and execute their transactions, the Ethereum virtual machine is just the Ethereum version of that, which is responsible for executing smart contracts. So Ethereum virtual machine is a DApp, which is a decentralized application. And so the Ethereum virtual machine actually runs on any node of the Ethereum blockchain. So earlier in these meetings, we talked about how everything in a blockchain is distributed, meaning that the data is stored on every single participant of the blockchain. So the Ethereum virtual machine actually has all its memory and all its like its data, it's like code. It's stored on every single node on the Ethereum blockchain. Why don't we talk a little bit about how exactly does the Ethereum virtual machine work? If you would like, actually, you could also just search up the open source code. It's available, and that's really cool. So if you want to take a look, you can. Ethereum virtual machine works in a few steps. First is smart contract development. So what that means is developers write smart contracts in various programming languages, which are then compiled by the Ethereum virtual machine which are then compiled by the Ethereum virtual machine and then deployed through the network by transaction. So what that means is essentially the developers code the smart contracts into the Ethereum virtual machine, and the Ethereum virtual machine is then able to process smart contracts that are created through transactions in the network. And second step is obviously users creating transactions, and these transactions are then sent to the Ethereum virtual machine. And then third step is the execution of these transactions. So what happens is when I talked about how the Ethereum virtual machine is distributed across all nodes, it's actually running in every single participant in the blockchain. So the code is running, or if you're familiar with programming, there's an instance of the Ethereum virtual machine that is created in every single node that runs each transaction on the blockchain. And then once the Ethereum virtual machine code and execution is run and the transaction is executed on every single participant on the blockchain, then the central sort of Ethereum virtual machine processes this it sort of reaches a consensus, and then these transactions and then and blocks are then uploaded to the blockchain. And then, so that's what you can see with the image here, program counter and stack. So essentially, every single computer runs its own thing. That's a program counter image. And then they all stack together, and then it gets processed and by the central Ethereum virtual machine, and then it gets uploaded. And of course, the Ethereum virtual machine can't just do this for free. So there's something called gas. There's a gas fee. So when you drive your car or when you want to do something, there's usually some cost associated with that. So in the case of Ethereum virtual machine, in order to utilize the power of the Ethereum virtual machine, people have to pay a gas fee. So that's why you might see when you start any crypto transaction, for example, that there's a gas fee involved. So you have to pay a little bit amount of money in order to pay for the virtual machine, Ethereum virtual machine, to actually process your transaction. And then once all of this is finalized, of course, the transactions are approved, the block is approved, and they're uploaded to the blockchain. We can talk a little bit about how the Ethereum virtual machine is actually built. So what it sort of looks like to better understand how it works. So essentially, there's different states of the Ethereum virtual machine. The first state is the persistent state. So essentially, each smart contract has its own storage of information, and then that's stored on the blockchain. And so this allows smart contracts to maintain their state throughout each contract. So think of it as a final variable, a permanent variable. Second is a global state. So these are just different levels of the Ethereum virtual blockchain, Ethereum virtual machine. And the global state is essentially the overall Ethereum virtual machine that maintains a global state, or like a state of everything that includes all accounts and their balances. So it's essentially something that stores the information of every user and their account and their balance on the blockchain. And so using these methods, the Ethereum virtual blockchain or the Ethereum virtual machine is able to power Ethereum blockchain.